Welcome back, learners. And as we have said, we are going to take our main idea being the pure substances and break it into three smaller concepts. So you're going to start with the elements and compounds. So we need to be able to describe what pure substances are. So a pure substance is a matter that consists of the same material throughout. So if it's the same throughout a chemical reaction, it is going to be a pure substance. So there are two classes that exist, namely we have elements and then we have compounds. So pure substances are elements and compounds. And then also, an element is a pure substance that will not break down into other substances. So regardless of how many times you try to break it, it will always remain that particular element. So this means that you can't take it apart to form other substances. So if you take a certain element and you try to break it into smaller pieces, it won't form new different things. It will still be the same particular element. For an example, we have zinc here. Zinc is an element because we're finding it in the periodic table. And then because it's an element, it is also a pure substance, since it is also made up of only one type of an atom, and it cannot be broken down to other substances. So even if you try to break this zinc apart, it is still going to maintain its property of being a zinc and also being a metal as per the periodic table. And as again we have said that an element is made of only one type of an atom. That's very important to note. Right, now we said we have an element and a compound. Those ones are pure substances. Now looking at a compound, that is made when two or more different atoms are chemically bonded together. Important, two or more atoms that are different and when they are chemically bonded together. So compounds cannot be broken down except by a chemical process. So for you to be able to break down a compound, you need to use some chemical processes. So when compounds break, they break into other pure substances called an element. For an example, if we take salt, our NaCl, and we try to break it, we're going to break this NaCl into chlorine and sodium. So it breaks into other pure substances called an element. Because initially it was a compound of two different elements that were bonded together. Now it breaks into other pure substances called elements as well. Right. A compound breaks by a chemical means through the decomposition reaction. So for us to be able to break a compound, we need to use this reaction called a decomposition reaction. So what is a decomposition reaction? That is a chemical reaction in which a single compound is broken down to produce two or more smaller substances. So we take one compound and then we break it apart into two or more smaller substances. And remember that those smaller substances are still pure substances called elements. For an example, when we break up a compound into smaller substances called elements, we're going to use the method of heating or the method of electrolysis. So those are two methods that are used to break down a single compound to form smaller substances. So for an example, we can take this example of AB. So AB could be any particular compound whereby we supply that compound with energy. And then that energy can either be in a form of heat and electricity. Remember that those two methods are used to break down a compound into two smaller substances. So now we're taking this AB compound and then we supply it with energy. It is going to break into a substance A and substance B. And remember that substance A is an element and substance B is also an element. And those two substances are different from each other. If now we're to be specific and say now we are supplying a specific type of energy being heat, we're going to take another compound CD, and it could be any compound, and then we supply that with heat energy, and then that particular compound, it is going to break into two smaller substances. That is going to be C and D. And please note that those two substances are elements and they are also different. And then we can also use electricity to break a compound to form again two small substances. And as you are seeing here, we used a certain compound, a compound EF. And we used electricity to break that particular compound into smaller substances, which are elements, and those substances are E and F. And please note that again, those two substances, they are different. Right. Compounds, again, as pure substances, they have formulas that show a fixed ratio of the atoms that make them up. A compound has different properties than the elements that make it up. For instance, if you were to look at this, if we take a compound H2O, which is your water, it is combined or chemically bonded in a fixed ratio. That is to say, for every 2 hydrogen atoms, it must chemically bond with 1 oxygen atom to make that one particular compound. So this ratio is always fixed. You can never find that water has a chemical formula of H3O. The ratio between the hydrogen and water is always fixed, and it is always H2O. Let's erase that. And then we also know that a compound has different properties than the elements that make it up. We do know that a hydrogen is a gas, and also the oxygen is also a gas. So when two gases chemically bond together, they form a liquid. So that liquid has different properties as compared to the elements that made it up, which were both gases. Now, the common examples of these two things, the elements and the compounds being pure substances, we have gold, nitrogen, potassium, helium, magnesium, and copper. The trick here to know is that every element that you are seeing here, it is found in the periodic table. So if we can find it in the periodic table, it is an element. And if it's an element, it is a pure substance. Now, a combination or a bond between two elements gives us compounds, and those compounds are still pure substances. For an example, we can have carbon dioxide, which is a bond between carbon and oxygen. And as we can see, there's a specific fixed ratio that for every 1 carbon, there must be 2 oxygens. There must be 2 oxygen atoms that are chemically bonded to form carbon dioxide. Then we also have sodium chloride, which is NaCl, 1:1. And then we have water, as we have discussed, being H2O, 2 hydrogen atoms chemically bonded with 1 oxygen atom. Then we have glucose, hydrogen peroxide, and then also have sulfur dioxide. So all of these compounds, they each have their unique specific ratio. So we can't have one ratio of one compound being the same as the ratio of the other compound. So we can't have the ratio of carbon dioxide be the same ratio as that of a glucose. So those are 2 different compounds, and therefore they will have 2 different ratios. Right. Moving on to our second concept, that's now the formation of compounds and the breaking of our compounds through the decomposition reaction by either using heat or electricity. We are going to have that compounds are formed when pure substances are composed of multiple atoms, which are 2 or more. Then when those 2 or more atoms are chemically bonded to one another, they form a compound. The atoms in each compound are always chemically bonded in a fixed ratio. As we have said, there's always a specific ratio for a certain compound. And then that ratio is indicated by the subscripts, which are the numbers at the bottom of the chemical formula. In the case of this one, we have the 2, which is a subscript. The 2 here also is a subscript, and the 3, that's a subscript. It indicates the ratio as per the compound. For instance, we are using H2O as an example that for every 2 hydrogen atoms, there must be 1 oxygen atom. For every 1 nitrogen atom, there must be 3 hydrogen atoms. When those are chemically bonded together, they form this particular compound called ammonia. And we know that we can have a sodium, chlorine, chemically bonded together to form sodium chloride. And as you can see, that these elements, they are different. And the compound that is formed is also different from the elements that made it up. The sodium is a metal found in the periodic table, And then our chlorine is a gas also found in the periodic table. But now when a metal and a gas react together, they're going to form this particular compound called a sodium chloride. So they will only form this particular compound if they react in a specific ratio. And the ratio, as you know, it is that for every one sodium atom, there must be one chlorine atom. And this is just reiterating that the properties of compounds are very different from the properties of the elements from which they are made. We have seen that sodium is a metal, chlorine is a gas, but when they react together, they form something else. And that something else is totally different from the two elements. So now we need to look at how these two substances react. So from the product given here, we are seeing that for every one atom of sodium, there must be one other atom of chlorine. So that means one sodium atom is going to react with one chlorine atom to form sodium chloride. But remember that chlorine is a diatomic molecule written with the 2, so it's Cl2. So if one sodium atom reacts with one chlorine atom to form the NaCl, what then happens to the other chlorine? So that is why we need another sodium atom so that it can react with the remaining chlorine atom again to form the sodium chloride, which is one sodium atom reacting with another chlorine atom. So this chemical equation for this particular model can be written as, so we have 2Na plus, remember, chlorine is a diatomic molecule, Cl2, reacting to form 2NaCl. Now, why are we writing the 2's? Because, as you can see from the model, we have one sodium and another sodium. So the coefficient, the number written in front of the chemical formula, tells us how many molecules of that particular substance we have. And then the Cl2, so the 2 written as a subscript there, tells us how many atoms of this particular compound we have. And then lastly, the 2 as a coefficient also tells us that we have 2 molecules of sodium chloride. So moving on. We also need to remember that the properties of compounds are very different from the properties of the elements from which they are made. On this picture here, we know that hydrogen is a gas. Same thing applies with the oxygen. Both of those are gases. However, should they chemically bond and chemically react together, they're going to form water, which is a liquid, which then supports the statement that the product that are formed from two different substances, they're going to have different properties. The properties of the reactants were gases, but the liquid is the product is a liquid. So as we can see again here, for us to be able to form the H2O, we need 2 hydrogen atoms and 1 oxygen atom. However, oxygen is a diatomic molecule, so it's written as with the 2. So for us to be able to have these 2 waters as we can have here, we need 1, 2, 3, 4 hydrogen atoms and 2 oxygen atoms, which now are taken care of because oxygen is a diatomic molecule. So to react with everything, we need 2 hydrogen atoms again. Remember again, hydrogen atom is also another diatomic molecule. So we have H2 and another H2 together, giving us the 2 as the coefficient. Before we go on to our next concept, let's quickly take an ad break and I'll see you just after this.